In this video, we will talk about the average value of the function. The average value of a finite number of terms, it's relatively easy to compute because we have to take all of the numbers and divide, or we have to take all of the numbers, add them together and divide by n, which is amount of the numbers. Yeah? The sum and divide by the number n. And that's relatively easy if we have the finite number of terms. What about if we would like to find the average value of the function on a certain interval? Then at first, it looks like the task is impossible because we do have infinitely many values of the function on that interval. So what we can do, we have to try to look for some tool, mathematical tool, calculus tool, and we saw this in the definition of a definite integral. We saw the addition of the values of the function, and that this indicates that we actually add all of the values, infinitely many values on the interval between a and b. But what it is, this equation, it's the Riemann sum, and at the moment, this equation represents the areas of all of the rectangles that we create. We create n of them, and we can see that's the example. And let's just remind each the width of each rectangle, it's delta x, and the height is the value of the function. It's the value of the function. And if we would like to find the area of one rectangle, it will be delta x times f of x sub I. Delta x, it's calculated the way that we will take the entire interval from a to b, which is b minus a, that's the length, and we will divide by number of these stripes, rectangles. And that's what we can see. This is actually delta x. And then delta x, which is base times height, base times another height, base, height. So this indicates the areas of all of the rectangles. Adding together, we approximating the area under the curve. And we call this Riemann sum. Yes, we remember Riemann sum. If we have infinitely many of them, which we will create a limit of the Riemann sum, it's a definite integral. Let's see. Let's take this equation because let's actually have a look at one more time. We see, yes, when we factor out the delta x, that's what I did, we actually see the addition of infinitely many values of the function, which I can even say all of the values of the function, yeah, from A to B. Yeah? And all of the values of the function, addition, that's what we need. And we can see division by n. N is a number of these values. That's actually the average value of the function. Add all of the numbers and divide by that amount of the numbers. Yeah? Let's try to take this equation and solve for this addition divided by n. I copy this equation. That's we are interested with this addition dividing by n. But first of all, we know we have to indicate that we have infinitely, I moved that n on this side. And we have to indicate that we have infinitely many of this, of these values, the rectangles, if we will think about the area. Okay, that means I indicated n is infinity, and now it looks like a limit of the Riemann sum. Limit of the Riemann sum, which is on the left-hand side, is a definite integral between a and b of the function f of x. And now again, one more time, we have to solve this equation for this, because this is the average value of the function. We will just divide both sides by b minus a, the length of an interval. And that's the definition of an average value of the function. We will just integrate a function and divide by b minus a, which is the length between a and b. And I have one more notation with the sigma, but this is the average value of the function. Integral divided by b minus a. We know where this comes from. Okay. average value of an integrable function f on the interval from a to b is equal to integral of the function f of x dx from a to b divided by b minus a, okay? Formula is the formula, but I'm happy that you know where this comes from, because this includes the addition of infinitely many values, n is infinity, and divided by n number of these values. Okay, and for instance, find the average value of the function x times e to the 3x, which this is the graph, on the interval between 0 and 4. Okay, let's just put 0 and 4 is somewhere, it's not on my graph, but that's what we will try to find out. Probably it's a big number because function e exponential, it's quite, yes, it's growing quite fast. Okay, but what we have to do, we have to take 4 minus 0, which of course is 4, integrate between 4 and 0 our function. And this is the average value of the function. I believe we have to use integration by parts, okay, because we have x e to the x. Let's try integration by parts, u, du, dv, and v. And I will put x as a u, derivative of x is 1 dx, and then e to the 3x dx is my dv, and the antiderivative is 1/3 e to the 3x. Because when we will differentiate, we will get, oh, not nice. And integration by parts, we remember u times v, v du. U times v minus integral of v du. That's the integration by parts. Let's see what we will get. That means the new concept, average value of the function, it's relatively easy, but now we have to get back to our integration techniques. Okay, u times v, x times 1/3 e to the 3x minus the integral of 1/3 e to the 3x times 1 dx. Okay, 1/4 x over 3 e to the 3x, and integral of 1/3 is a constant. Integral of e to the 3x is 1/3 e to the 3x. Everything must be evaluated from 0 to 4. Okay, let's try. When we substitute 4, we will have 4/3 e to the power of 12 and 1/9 e to the power of 12. And then minus, when we substitute 0 is 0, and this will be 1/9 e to the power of 0 is 1. We will have this value. Okay, and the final number is, this will be 3/12 over 9. 12 minus 1 is 11 over 9. And this one is just 1/9. Okay. Maybe we can factor out 1/9. 9 times 4 is 36. And then we will have 11 e to the power of 12 minus 1. And we will leave it like this. It's a big number because 11 e to the power of 12 is a big number. Okay, that's the first question we did. It's purely theoretical, but we applied the average value formula and integration by parts. Let's look at the next example. Oh, it's solved? No. Okay, let's just analyze. Find the average value of the function sine of x on the interval between 0 and pi. The pink curve is the sine curve. Okay. And the average value will be the integral of sine of t dt. Okay. We can say x, sine of x, since we have everything in terms of x, from 0 to pi, and 1 over pi. Pi is the length of the interval between 0 and pi. Integral of sine of x is negative cosine of x Yeah? 1 over pi stays, and we will evaluate between 0 and pi. Let's actually make sure that this is the correct answer. Cosine of pi minus cosine of 0. Let's keep this. Cosine of pi is -1. Cosine of 0 is 1. We will subtract, okay? So we have -2 times -1. It will be +2 over pi. Yes, that's the correct answer. We did verify. Also, we do have one theorem that if function, because we can see this is like the average value, and it looks like in the middle, but that average value, this horizontal line, will always intersect the curve, and the point, the x values, will always fall between 0 and pi, yeah, like a mean value theorem. Just in case, I can show you this theorem, the mean value theorem for integrals. If f is a continuous function on a to b, then there exists a value c in that interval, that the x values, the corresponding value for that c, which is, it's the average value, which I can call it m. Yeah, c sub 1, c sub 2, we can have even more. That means always there exists a number c, yeah, between a and b, that the corresponding value is actually the average value. Okay. Which we saw this, yeah? 2 over pi is between, 2 over pi is the average value, and the corresponding x are between 0 and pi. We don't know exactly what are the values, but they exist between 0 and pi. Okay. And I have one more question, and we will be done with the average value, and you can enjoy your assignments. The temperature in Celsius at time t in hours in Art Museum varies according to the function t of t 20 plus 5 cosine pi over 12t. Okay, I can maybe copy this function, 20 plus 5 cosine pi over 12t. Okay, and find the average temperature over the time period from 2 to 6, from 2 hours to 6 hours. Okay. Average temperature is just the integral of the function t of t dt between 2 and 6, and we will divide by 4. I did subtract the difference between the length of the interval, which is 4. Okay, let's see. Integral from 2 to 6, 20 plus 5 cosine of pi over 12t with respect to t dt. Okay, let's try to integrate. That will be the value. Integral of 20 dt is 20t, constant 5. Integral of cosine is actually just sine of the same angle, and we will divide by 12 over pi, right? Because that's the coefficient. We always divide by the coefficient of t. T is linear from 2 to 6. Okay, let's see. Let's substitute 6. 6 times 20, 120 plus 5 sine of, when we put 6, pi over 12 times 6 is pi over 2 times 12. Actually, let me multiply, because this is pi over 12 over pi. I will multiply by 5. It will be 5 times 12 is 60 over pi, and then sine of pi over 2 minus, multiply by 2. 2 times 20, 40, minus, not 5, 60 over pi, right? I did multiply pi times, I mean 5 times 12, 60 over pi, and then sine of pi over 6, because when we put 2. Okay, what we have? 120 and minus 40 is 80. And then sine of pi over 2, yeah, you definitely know that this value is 1. And this value is 1/2. Then this is 60 over pi, minus 40 I took care, and this will be 30 over pi, right? Because we will multiply. Okay, that means the final answer is 1/4 80 plus 30 over pi. We can still distribute 1/4. It will be 20 plus 15 over 2 pi, I believe, right? Because when we will divide just by 2. Okay, that means we will not convert, we will not use the calculator, but this is the average temperature in Celsius. In Celsius. 2 times 3 is 6, 15 divided by 6 is a little bit more than 2, 22, around 23 Celsius. That's a rough calculation without the calculator. Okay, thank you very much.